about that. And that's why I need to speak in monotone. Welcome, Karl.
Thank you, Sirius Sakke. All right, welcome from my side as well. Welcome to the stream. Welcome back to the meet space for all of us here. It's great to be back at physical events. Great to be back at IglooConf. It's a little bit warmer than I remember IglooConf being, but no complaints whatsoever. So for the next 60 minutes, whatever. Yeah, Sakke was just telling me that I can just fill however long of a space between your taking away from your small break before this session. So 60 minutes plus Q&A. Just kidding, including Q&A if those come up. I'm still going to be here for the hallway track in any case. So we are going to talk about security. We are going to talk about kind of a lessons learned, war stories type of session, similar to what Rick did, but a little bit more serious, I guess, based on how I was introduced here. And the first thing about security is that we, of course, have a lot of regulatory and compliance and personal identifiable information sharing related regulation. And apparently Clicker does work. So one thing I was asked to do was to steal my previous presenter's personal data.
Who asked you to do that?
I cannot name them because of PII reasons. So I don't know why I'm doing this. This was in the requirements, and I guess I need to position myself somehow like I'm like this. But there was your chance. All right. Good. Well, welcome again. To talk about security. Why am I talking to you about security is that this is what I'm doing. Someone actually pays me to talk about security and do some security related stuff. I'm working at a consultancy company called EPAM, a global consultancy serving Fortune 2000 customers, mainly enterprise customers, very highly regulated areas, medical device makers, financial sector customers, and so forth. And I've been doing security related stuff and cloud related stuff for a number of years now, and this is basically a collection of my war stories and rants regarding these topics. Great. So our agenda or the plan for the session really is that we are going to talk about my definitions of some of these topics. What is cloud security from my perspective? I'm also trying to keep this a little bit more agnostic, so it's not only Azure specific stuff, but of course every now and then there might be some Azure terminology that I might accidentally slip in as well. And then we are going to talk about how our organizations are actually taking and how should the organizations actually take security within their cloud adoption journeys and within their information security programs and cyber defense programs. And I'm going to define something that I call a cloud security program and how it's done and how it maybe should be done instead. And then we are spending the last roughly half of the session on a little bit more technical topics. We are going to talk about cloud security architecture. We are going to map that into hopefully familiar terminology to you if you're familiar with cloud adoption frameworks, well-architected frameworks, and so forth. And then wrapping that up with some lessons learned, indeed. Great. Let's get started then. So first things first. When talking about cloud security, it's no longer a question, as I alluded in the panel earlier yesterday as well, it's no longer really a question about whether or not organizations will go to the cloud at all or ever. It's now a question that we happen to be in the cloud already. What do we do now? How do we secure this cloud thing that we accidentally stumbled upon? Apologies for the lags there. And basically cloud really was kind of going through this test of scalability, elasticity with the pandemic. A lot of organizations needed to scale to support remote work. A lot of organizations needed to break up their existing security models and no longer just kind of be stuck in this analysis paralysis mode of waiting for some big change in cloud vendor side or big change in the regulatory space to take that leap. So we're already there. We need to figure out how to make this take back the technical debt that we incurred with this maybe 2 or 3 week jump during the first weeks of the pandemic, when everything was moved to the cloud, every network was opened, and now we kind of have to figure out where do we go from here. And where do we go? Well, we go towards something what I call cloud native security. And by cloud native, I don't mean Kubernetes, I don't mean containers, I don't mean anything to do with cloud native computing foundation. There is, of course, a little bit of term gap there, but basically I'm looking at something that feels a little bit more built for the cloud instead of something that's kind of bolted on top of the cloud. Is something that we used to do on security and that just shifted or lifted and shifted into that cloud environment. So what does it look like? It's basically looking something like this. It's very different from what we used to do. It's no longer based on buying some specific products, buying some from that same network vendor or firewall vendor that we used to buy for a number of years, maybe already. It's no longer just an implementation project, kind of fire and forget. It's not about outsourcing security to something as a service or something as a managed service. Hard to describe what is really the difference there besides the buzzwords and adding more letters to those acronyms. And it's really something that requires you to acquire new skills. If you're coming from the security background, you need to really start to learn about cloud, not just map your existing data center tiering system into the cloud world or other type of approaches. You actually really need to understand how is the cloud built and what are your peers, what are the developers building on top of the cloud. And similarly, if you are coming from the cloud background and not the security background, you basically need to extend your remit into not just thinking about availability, features, cost, scale, but also security now. And it's really something that's built individually for each of the clouds, and that's the cloud native part. You really can't use something that's using the least common denominator across all of the clouds, maybe something that's a virtual appliance just stepped or bolted on into your virtual network. That doesn't cover the bulk of it when we are talking about impactful coverage for cloud native and cloud security. So it's really built into the cloud. It's not bolted on top of the cloud environments with something that's just basically, I mean, if you peel off the covers, you'll see that it was the janitor or it was still the old school on-premises networking component still. So regarding those skills and regarding those investments, there's basically this asymmetry of cloud security that I see in a lot of organizations, that they have these massive investments in this bigger claw. Thank you. Anatomy of crabs is always interesting. So in this bigger claw and very overpowered bigger claw, very asymmetrically overpowered claw, we have this investment into traditional security components like firewalls, like network sniffers, network flushers, all of these next generation or whichever generation firewalls and so forth. And I don't know if you even see, but there's this teeny tiny part, this other claw here, which is all about the cloud security. And this is something that might maybe come from the same vendor, now this older vendor is also selling you something related to the cloud, and that's why you happen to be asked to use it. Or it can be something that's maybe is a completely new environment. You've heard that now that you are using containers, and you've heard that you need to do some container scanning, for example. There's this new set of tools and technologies and just stuff that we need to learn. And this is really the gap that we need to bridge. We really need to get this at least closer to each other. So how do we do that? So we really do need to understand again, if you're coming from the cloud world, this is something that you should already have seen, you should already have heard about this thing. It's on the very definition of public cloud platforms, hyperscale cloud platforms. It's a shared cloud responsibility matrix. From the security point of view, there is a bit of a difference, though, when we start to look at this in more detail. So if for some reason you happen to have come to IglooConf and you haven't seen this, a quick walkthrough, if you come from the on-premises side, there towards the right of, not your screen, but of your head, it's an interesting choice of terminology coming back to the physical conferences. So if you're coming from the on-premises side and moving towards the various abstraction layers or service models of the cloud, you're basically giving up the available security controls for you. You used to be able to control everything up from the physical side of things, including the physical networking part, including the physical security, of course, all the way from there up to actual physical servers, all the way from there, including the virtual machines, operating systems in those, middleware, and so forth and so forth. And when we go to the infrastructure as a service, we have a lot of those available, but not everything. And we need to rely on how has a specific cloud provider that we are using, for example, how has Azure built these services, and which part is actually just a generic description of this is what we aim to do, and which part is actually about something that's documentable or admissible to auditors or admissible to your internal auditors. So this is about finding things from documentation, from docs.microsoft.com, from Trust Center, from all of these different locations. But you have some controls available for you there. You have the least security built in. There's more responsibilities for you when you're working on the infrastructure as a side, and where you're moving towards platform as a service and functions as a service, containers as a service, etc., all the way up to the software as a service. You're getting more integrated security, but you have less controls available to you to change those. You just might need to be able to go with the flow. And that really means that when we start looking at some of these services in more detail, we start to understand that even though we might have thought about some of these services as being on the very managed side of things, having a lot of integrated security, and there not being a lot of operational responsibilities or other controls that are our responsibility, in fact, there might be actually quite a bit of things. Here's an example of something that quite often gets misunderstood or misinterpreted. The managed Kubernetes service, like AKS in Azure. It's managed in terms of someone else is actually downloading patches to your nodes. It's managed in terms of someone else is spinning these clusters up. You can do a lot of automation in there. You still need to reboot your nodes after those patches have been installed. You still need to do a lot of hardening. You still need to do a lot of monitoring. There's a lot of responsibilities that are up to you. There's several layers of networking, in fact, that are fully under your control. Egress control, ingress control, in and out of the cluster itself, actual role-based access control within the cluster, and so forth. So in terms of Kubernetes, basically we have the Kubernetes control plane environment like kube DNS, API servers, we used to have dashboards, all of those that are handled by Microsoft. And then everything else, everything that's running on those Kubernetes namespaces that you see are your responsibility there. So I really, really recommend you look at, and we are coming back to this when we are talking about these lessons learned, I really recommend you kind of decompose your cloud services in terms of understanding what's available built in terms of security, what is your responsibility, and what can you even do about any of this. And then hopefully mapping that into your actual requirements regarding security. So now that we have the crab part away, we can talk about the cloud security programs. How do organizations start putting these various things together, and how maybe they should be doing that? So there is this balancing act regarding enterprise security overall, but enterprise cloud security specifically. On one hand, you have the options of tying the screws very, very loose, implementing a lot of restrictive controls in terms of identity and access management, like policies, like RBAC, taking away a lot of access, putting in place a lot of order remediation and so forth, taking away the options for self-service. That's great for security, that's great for our auditors. That's not so great for our speed, our time to market, maybe our whole reasons for going for cloud. If we actually have made a conscious decision of going for the cloud through building some sort of a cloud strategy, hopefully supported by the business, not just accidentally trying cloud out, chances are that you are doing that because you want to beat your competitors to the market when you're building new products. You maybe want some new innovation. You want to be able to use these new AI and machine learning tools that you cannot just do at all on the cloud or without the cloud, or the cost of doing that will be just so cost prohibitive. So you need to enable that part of the business, or you need to specifically enable that part of those developers who want to use these new fancy tools that you haven't had time to lock down yet. So that's the balancing act that you need to play. Because if you don't do that, of course, as any developer knows, cloud is just cloud. I just spin up a new subscription on my own credit card or even my whatever environment. I can do all of those things on my own. The shadow cloud approach is very easy for the developers to do, just for development and test, or just for staging, or just until we get the real stuff running. And you don't want to go there because then you really lose the control. The press doesn't care at all if and when something goes wrong and a developer accidentally opens up or does something wrong from a security perspective in an environment that's their own. If it stays or if it's associated to your company, then you need to deal with it in any case. Most organizations I see tend to overcompensate and balance one or the other. They might be kind of fully trying to embrace this federated, go do anything you want, we'll catch up, don't worry about it. And then they might come back again, and it might be this pendulum that's swinging back and forth about centralized control and fully decentralized kind of do what you wish. I would, of course, like the scales tipped a little bit more towards the security side from this perspective. But again, it's the balancing act. You don't want to tie these environments so closely monitor or closely controlled environments that you limit innovation there or limit the speed to market. Kind of the classical example will be that any cloud service that your developers can use needs to go through internal security review. And again, from a Asymmetry perspective, you might have maybe 100 developers in your organization and maybe 10 security people, or even less. So of course, the chances are that the security people are not aware of the cloud yet, so they will take a little bit more time. And even if they will be as up to speed regarding cloud as you, the developers, are, you will still need to catch up in the sheer volume of the ideas and the services that you will want to use. So perhaps you can shift left that security part as well by bringing developers the tools to understand how to secure this environment, even if there isn't a playbook or internal checklist for this specific service yet, what are the things that you can check in general and how to apply those in new environments. So the whole problem space regarding cloud security programs is that how do we kind of keep building cloud security policies, and by policies I don't necessarily mean Azure policies, I mean policies in terms of humans deciding that these are the rules how we play within our cloud, this environment. So how do we design these types of rules, these types of policies that are competitive, keep us competitive or get us into a competitive mode, and how do we also make that, that secure? So it's kind of a catch-up job as well. So from my perspective, this is as a consultant, I will come in. At that point, I will talk to the customer and an enterprise there. I will talk about a cloud security program being defined, being something that defines the processes, policies, and controls to secure the cloud environment. And usually what happens at that point is that basically this. So this is what happens when you look at this very strict definition of a cloud security program. It's quite acutely aware of how security is perceived, perhaps, by a lot of developers. It's not very competitive friendly. It's not very understandable in terms of, well, what type of an Azure service do I always need to go for premium, or what's the impact for me? So instead of defining this as we used to define this in the kind of world where security was this kind of ivory tower of its own, or kind of a stamp of approval at the end of the product development cycle, I like to define this a little bit more user-friendly. But again, it's still jargon for a lot of people, but it's hopefully a step closer to the real world. So from my perspective, I don't really care about those formal definitions. I care that you understand as an organization what is the appetite for risk for you, how far are you expected to go. It's not, because security is not just black and white. We can invest infinite amounts of security dollars or security controls and still not get into the level that's needed. We need to understand what's enough and where to put those story points, for example. So we need to understand what is our risk appetite, understand it in terms of not just something that's in a nice piece of consultancy paper that's locked in the safe, and when auditors come, you will just tell them that this is the risk menu for us, but we need to circulate and get some awareness around that across our environment. And after that, we need to understand what sort of security controls are then appropriate. So, for example, if we need to keep network traffic keep all cloud traffic in our network, do we need to go for private link? Do we need to just make sure that there's an access control list defined for the platform as a service components that we are using? What's the appropriate control for us to use in these types of scenarios? You don't want to over-engineer it just because security told me so, but you need to understand what's the appropriate measure for these risks. So basically, this is about minimizing that asymmetry of the clause. And the way enterprises work quite often result into this kind of analysis paralysis that there's lots of different committees, lots of different feedback loops, and again, lots of different policies that are impacting all of this before you actually get into the meat, which is, again, this controls piece here. So in here we have the actual policies, guidelines, policies, guidelines, and the actual security controls, which are some things that we actually apply in our cloud environment. It might be adding a firewall, it might be clicking on the TLS version enforcement, it might be actually redesigning your platform. There are different actual deliverables or different impacts of what is a control, but this is the actual piece that gets translated into a backlog. If you're a developer, this gets translated into a cost. If you're an operator, this gets translated into mitigating an established security threat into from an unacceptable level into an acceptable level. So this might not be the right level of detail and level of analysis paralysis, but the heart is in the right place in this. The end result, the outcome is the security controls there. So once you know that eventually you will just need to have a reason to invest or on identifying or applying some security controls, that kind of a program of different committees or projects or someone building development, someone doing risk assessment, all of that security program work going on. The outcome of that are those security controls. And those security controls then essentially affect your cloud environment. Essentially, they affect your cloud architecture. So this is the implementation part of that, a little bit more abstract part of that work. So cloud security architecture, from my perspective, kind of what it comes down to is basically a list of these controls. It's a collection of security controls for your cloud environment. And it doesn't have to be, depending if you are using multiple clouds, you can still reuse the same cloud security architecture. But again, the actual controls need to be cloud native. So you can say that you need to enforce TLS 1.2, for example. The actual security control is different when we are implementing that for Elastic Beanstalk versus if we are implementing that for Azure App Service, right? Eventually, it's about protecting the confidentiality, integrity, and availability of our assets, our data, our security, our components in that overall architecture, not just the security architecture. And again, it needs to be unique to your organization's risk appetite. So how does this look like? So if you work with these CAFs and WAFs and that sort of stuff, you may be familiar with the approach of having this secured cloud platform in the bottom. It might be one or more landing zones that you have in there. Eventually, that's just your cloud environment. It's an Azure Active Directory tenant that is tied into multiple Azure subscriptions. You might have multiple levels of abstractions and grouping in there. You might have management groups, you might have nested management groups, but eventually it's some sort of a secured cloud platform that you have on the bottom of all of this. And into this cloud platform, you are then basically dropping these cloud workloads. And cloud workloads are just a specific way of calling applications. They might be completely new, something custom that you're building, or they might be something that you are migrating from an existing environment. And usually this work is then split into having these centralized teams like the CISO organization working with these landing zones, working with this centralized platform, and then a little bit leaving the actual workload part a little bit disconnected. A little bit, again, we are having this potential for this asymmetry here. But how can we bridge these two worlds in, for example, this CAF model is to use standardized templatized environments. So each workload actually consists of a number of standardized products, internal versions of the cloud services that you're using. So instead of each of the workload team, each of the application team building their own template, Bicep, ARM, Terraform, whatever, building their own infrastructure as code template for each of the services that they are using, and potentially needing to introduce that same security analysis each of the time they are taking into use of those products. You should look at centralizing those templates, having maybe a center of excellence type of team, or some other way of building a set of standardized templates of your cloud services, and that's where you can actually include your security controls. So if you have a workload that uses an Azure app service and I don't know, Cosmos DB, for example, then instead of that team working at building those services from scratch, figuring out what should we do, and maybe only realizing some of those security controls, you should look at centralizing, especially the more obscure or the harder to implement or harder to find security controls, and building those into these infrastructure as code templates. And that's how we can make this program more scalable as well, and that's how we can actually support the part of the organization that once has that need for speed. And if we approach it like this, we can start to again shift left. And this is one example of that. So here I'm just using a tool called Chekhov, which is one of these template security scanning tools. You can run it in your CI/CD. So at that point, it will be called infrastructure as code, static application security testing. So infrastructure as code, SAST. Or if you can go even more left from the deployment perspective, and you can actually implement this. In the development workflow. So already at the time when you are building that template, or if you are using that template built by the centralized team, you can introduce some standardized security tests here. So this is just an example with Terraform, because that's what I happen to have in here. I'm building a virtual machine. It happens to be a Linux virtual machine, so it's giving me in my Visual Studio Code, because I have the Chekhov extension installed, it's giving me kind of intelligence regarding security that, hey, have you thought about, not implementing username and password in your Linux virtual machine, but maybe using SSH logging instead. Good security patterns and good security recommendations, but getting those out of that vault for auditors and kind of in the screens, in the face of the developers. And that's what this shifting left means. So that's for the products that combined make those into those workloads, into those applications. And a lot of the security controls that can be done centrally or have to be done centrally are then applied into that platform that is hosting those products. And in that platform layer, we can implement identity and access management, we can implement other types of security controls. I'm just going to run briefly some examples here on the IAM side. Usually this is very slow part, because you need to integrate with your organization's existing IAM processes. If you need to define a IAM product for each role-based access control assignment, or for each key vault role that you have, or even for each secret that you are storing in a key vault, that's going to generate a lot of activities, a lot of slowness in your cloud adoption journey. So you can think about maybe putting some self-service in place there, or you can think about automating some of those parts of creating those processes, instead of trying to catch up, trying to hire a little bit more IAM process people as well. And once you start doing that, you actually start to realize that there's not just the control plane, but there's actually the data plane side of things, and there's some in-cluster roles, and there's lots of granularity for identity and access management there that you do need to keep on working on. It's a continuous effort. And then kind of the third step of the maturity model, or that evolution, is then to think about the overall life cycle of those workloads, of that environment as well. So essentially, even if you hardened the crap out of your cloud environments, you've taken all write access away from your developers, from your subscriptions or from your environments, and you only limit your access to deploy resources using templates that are built securely and are scanned against security rules, and you are centralizing that to a CI/CD pipeline where you are making those deployments. You still are left with having a single place of potential failure. Now you are abstracting away. Instead of hardening and monitoring if your subscription role-based access or your control plane access is hardened against user access, now you need to also check your CI/CD, and hopefully you only have one, but how can you know? So credential resharing is certainly an opportunity. And we only recently got access in Azure side, for example, of evaluating, adding some conditional access for these service principals. It was basically just a blank canvas. Anyone could have reused them, and a lot of organizations did, and a lot of malicious actors did, if you recall the Solorigate, for example. So basically it comes, again, from the process perspective, from the enterprise perspective. Either the IAM team needs to extend into understanding that it's not only about the product, if their mode of working is that they are spending 1 or 2 weeks or even 1 or 2 hours per each product that they need to build. For example, an SAP role for a specific user business functional role. Now they cannot scale that same model into the cloud because of those amount of those different roles and those entitlements. Remember that term when you look at some of those new branding changes from Microsoft, like that Entra and these other cloud identity related tools. So you need some sort of either reaching from the IAM side into a more scalable model, or building something that's hopefully not a shadow organization of that, but a cloud native mode of operating on that. And then another part that's in the platform side is this detection and monitoring. So this is basically two things. It's the traditional logging part, audit logging, making sure that our resources actually generate logs. A lot of Azure resources by default don't. This is an excellent piece that you can integrate into your products instead of for each developer trying to figure out for themselves what is the specific security log that I need to enable from this new service, because the name is always different. Instead of having to rework and reinvent the wheel on those, you can build that into that templatized product, and you can verify that centrally using Azure policies or other cloud security posture management tools that monitoring the platform level. Are your products doing what they are supposed to be doing? So you need to enforce those audit logs, and you need to decide where so you need to enforce the audit log emission. Your resources actually need to create those logs. As Web Application Firewall and Azure Key Vault notoriously do not create logs by default. At least for me, it's the first firewall that doesn't log that I've ever heard of. But there you go. Those are the things that you need to build into the product. And then you need to decide from a architectural perspective, where do you store those logs? Chances are that your team needs to have access to at least some part of the operational work in order to troubleshoot your front door or application gateway deployments. But you also need some sort of centralized logging place for your audit parts as well. And you need some sort of faster cycle to detect and respond to any security alerts, any security anomalies as well. So you need to store your logs and automatically enable create events and perhaps even incidents out of that, and basically create tickets for your security operations center team to mitigate or at least investigate those. So you need some sort of centralized logging architecture. Here's a very basic example. On the top, I have an application subscription, and on the bottom, I have another application subscription. They both have their own log analytics workspaces. So just a place where you can store all of your logs. That is, write once, read many type of storage. So it's great. You can run your custom queries in there. You can be the Jack Cousteau of your logging life. That's fantastic. And then you can also store from those same resources the logs in a separate location. There's a little bit of duplication. That's fine. There might be some cost impact, that's something that you need to decide and design together. But eventually, some sort of combination of this decentralized and centralized approach to logging architecture is what you'll most likely end up with. And it could be that instead of this being in Azure here, I don't know, this could be something else. And I can't really write at all, but that's good. I don't want to say that I'm talking about any specific vendors here. What I mean is that it doesn't have to be on the cloud. Did I just skip over a slide? Yes, I did. What I'm saying is that it doesn't have to be in the same cloud that you're working on. It can be somewhere else. And then the last part on the platform side is networking. It's a whole topic of its own. There's those private links. If you are using private links, it's basically egress cost for all of that traffic. So no longer traffic within the cloud is free because it's getting outside of your own tenant, or it's getting outside of that free plane of existence. You might not want to implement that every time, but even you do, chances are that it's hard to implement, it's hard to troubleshoot, there is networking, there is addressing, there's lots of different topics that you need to think about. So a very good thing to centralize again. And then you need to figure out how to connect your different subscriptions, maybe different regions, maybe different clouds together as well. In the Azure space, of course, if you are working with these sovereign clouds, maybe clouds from the US government, maybe clouds from China. Those are in different network spaces. Those are in different Azure AD tenants and so forth. And then typically something that's part of the actual application design or the workload part, connecting the network planes of existence of the platform as a service side, infrastructure as a service side, and these various other as a service pieces of Azure. How do you connect your Power BI securely with your infrastructure as a service component, and how do you connect the same into your, let's say, Azure applications, Azure App Service web app, for example. A lot of network design, a lot of pricing impact, and so forth to think about. And then finally, something that a lot of us can do even on our own, we can add a web application firewall, even if you're using front door or an app gateway, it doesn't really matter. It's a good place where you can introduce security controls. It's something that you can tune on your own if you want to. If you want to have a lot of job security for yourself, use the built-in ones from the cloud provider. They're okay. Or you can go for a best-of-breed solution somewhere else, and you can also go for a managed service from somewhere else. Then you can actually bring in someone who has worked with or has even heard about, for example, Apache Mod Spark rules before and can tune them for you instead of you trying to troubleshoot. Why don't my health probes or why don't my application access get through my web application firewall there? Lots of options on that space. And then we move on to some of those lessons learned there as well. So identity and access management is really one of these pieces. I already talked about this quite a bit, but this is where I see a lot of organizations stabbing themselves, sometimes to death, really, because of this integrating not the technical integration. I can fairly, it's just a technical problem of integrating with your whatever IT service management tool you're using, not naming any names here, with your Azure Active Directory entitlement management. That's just a technical question. But implementing that part into your actual processes, where most chances are that if you are in a regulated environment that has spent a lot of time asymmetrically working on implementing network security and building a large IAM team with a lot of structured processes on onboarding new applications, chances are that changing that piece is going to take a long time. And if it's not done right, then I mentioned Solorigate earlier. This is what can happen when we introduce these kind of new cloud access types, such as managed identities or service principals. We need to understand what they are, and if we don't, we basically either overload the IAM organization altogether, or we end up basically in this shadow IT world within our existing tenant, where a same service principal is getting associated multiple different roles. It's getting, maybe even added multiple different credentials, and it's getting used to multiple different things. And then from a platform perspective, we don't know what is malicious, what is normal, and what is not. And that's when you can come in and take over an existing SSO, existing app registration that's built for something completely different, such as third-party application SSO. You can get your own credentials in, and you can start to elevate your access. You can start to move across that organization and find the weak spots, just like they did with Solorigate and those service principal reusable credentials. Now, on the cloud platform side, things are a little better now. Microsoft implemented in the UI limitations of how what's the maximum length of those credentials. But if you work with them, you might already know that it's only a UI change. The actual password or expiration or the credential expiration times can be still significantly high. So it's again still something that you need to work on. And this very much applies into these privileged roles. Usually we understand that owner and contributor are privileged roles, and that's fine when they are assigned to users. But when we are dealing with unmanaged roles and unmanaged identities, such as service principals, or federated accounts, or guest accounts, or shadow IT tenant accounts, or just temporary accounts, that's when it gets harder to monitor what is normal and what is not. Apologies for that. So one option is to build some self-service. You can build cloud account vending machines where you have those roles or where you have those service principals available as snackable sizes. It's something that you can go on and select in a self-service mode that I want this type of a credential. I need to be able to access, for example, these APIs with these types of roles. And instead of going through the same hoops that you maybe used to do earlier, kind of designing a business functional role and whatnot for that, you can just dynamically generate those. You can go through a verification if needed, and then deploy those to your users. So as a category of topics, if you want to learn a little bit more about that, kind of instead of IAC as code, infrastructure as code, it's now identity and access management as code, which is a bit of a topic of its own as well. You might have worked with Bicep or ARM templates or blueprints at one point where you'd also deploy the roles. Well, something similar you can also do with Azure in there as well, with native Azure roles as well. So besides identity and access management, another part that can go very wrong is the vulnerability management part. Again, a topic that you used to be doing in an enterprise already for ages. Chances are that this can be one of those asymmetric parts where you are spending already significant time, resources, and technology. But mapping that into the cloud world might not be as successful as or as easy as you might think, whatever your existing vendor for those vulnerability management tools says. You need to understand the scope. A lot of these services, if they are based on agents that need to be deployed into virtual machines, they can't have visibility into those other planes of networking existence without you actually connecting them. They don't have access to your platform as a service if they're deployed into infrastructure as a service and there's no network connectivity between them. Some of them are based on having access to the control plane of your environment. So basically you are granting a reader access to a third-party service who then reads everything that you have in the control plane, maybe reacts even based on events, such as from Azure Event Grid, and then alerts you or updates that inventory based on those changed events, and maybe even automatically mitigates some cloud control plane vulnerabilities. That's great, and that's where we can again, when we know that we deployed something secure, and over time we get an alert saying that now something has changed, we can build standardized ways of getting back into that secure state. If we actually have an understanding that what we are covering is actually everything that we are actually using, and that's not always easy to understand. And then there's, excuse me. And then there is containers. Very, very fun topic for vulnerability management, and a topic where you can really get into this signal noise problem quite fast. How do you know that when you scan your container on the deployment time, how do you know that the tons of CVs that you are getting, that these are relevant? How do you know that you actually need, where do you focus on fixing those, and how do you know, are you actually even using those containers anymore if you are working with a vulnerability management solution that's, for example, scanning your container registry? You then need to map into, okay, this was the version of the container that's in my registry, there are some vulnerabilities, and then need to check through all of the places where you could run your containers, and then there are dozens, Kubernetes, ACI, app service, and so forth. You need to go check all of those at runtime. Am I actually using this container? So it's again more of an asset inventory question rather than a vulnerability scanning question. There are tons of free tools that you can use to scan for vulnerabilities for those containers. Docker scan, for example, it's just a Docker command that you can integrate as part of your CD. Fantastic, you get the results. You may or not, you can fix them, or you can choose to ignore them. That's fine, but you at least get coverage at the right space. And when you're specifically working with Kubernetes, you can have services like Kubescape to look at the runtime security, or use tools like Kube Audit or Falco to actually look at the security hardening guidelines and security of the actual cluster itself, not necessarily the workloads that you are deploying into them. And something that just sounds very cool, but it's actually a very basic set of guidelines. The NSA has actually, together with CISA, introduced the hardening guides for Kubernetes and hardening guides for containers. It's basic stuff as such, don't build your containers as root, that sort of stuff. But it's still something, from a project perspective. Usually, if I'm asking an application security program, if I'm asking to implement security best practices or to meet compliance requirements, the answer from devs might not be the biggest hurrah as such. But if I'm telling them that, hey, now this is a fantastic project to implement NSA-grade security for your environment, that's usually achieved a little bit more enthusiastically. But again, a good free resource for you to look at. And then finally, we have the cloud solution and cloud service provider vulnerabilities themselves. We had ChaosDB, we had break information, we had just recently we had the Synapse vulnerability as well. This is something that as the cloud reaches more maturity, we get more usage of cloud, and with the more usage of cloud, we get more eyes looking at the cloud environment, looking at also accidentally breaking it, but also maliciously or intentionally trying to break these cloud clouds as well. So breaking the isolation models of these multi-tenant services is quite scary. But how can we mitigate this? It's again, when we are mapping this back into the shared responsibility model, for example, with ChaosDB, if you already knew what you were doing and you understood what was your responsibility, chances are that it was just a matter of inventory management checking, are we actually doing what we were supposed to be doing, or that we thought we were doing across all of our Cosmos accounts? And if yes, then we are good. Same with the Omigod, the VM agent that's deployed into all of the VMs in Azure, including Kubernetes. There's a massive vulnerability there as well. But if you understood that there is what are all of these agents installed into my VMs for me, what is the shared responsibility at that middleware part of my VMs, and if you understood that if it's a virtual net, if it's an infrastructure as a service, I'm responsible for protecting the network part as well, you were good. You could, if you managed to verify that by having an up-to-date inventory management system, after that you could just wait until the new patches were released and then implement those. Or in Cosmos's case, just do nothing and just wait because it's managed service, just wait until that gets fixed by the CSP. But in order to have that confidence when these things are at the level of they are hitting the news, chances are that someone calls your CISO or someone calls your CTO asking, are we vulnerable? What can we do about it? Or prove to me that we aren't vulnerable. You need to have understood that shared responsibility first, and you need to be able to implement those as part of your operational responsibilities of those incidents as well. I actually even had a slide on that, sorry. So when we are talking about the overall applications and overall supply chain, it's not just the applications that we are building ourselves. We might have dependencies. Those containers might have been built on top of some, however minimized, but still dependencies on images that are built by someone else. We need to understand who has built them, what are their responsibilities. Are we paying for a provider to get these hardened images, or are we using just something generically built by someone? And do we actually have we verified that these are actually provided? These images are from sources where they think they are. There have been cases where just by using a similar name for popular dependencies as a publisher, someone has been maliciously able to propagate their own images and their own dependencies instead of the public source, just by doing a little bit of better search engine optimization there. And then there's the impact of, if you're a US organization, you need to be able to start building these software bills of materials. There was an executive order recently on that. Basically, nothing really that you need to, as such, do yourself if you're not a US company, but you will see basically from a lot of these SAST tools and a lot of these software composition analysis tools, you'll start to see something called BOM or SPOM, software bill of materials, or just bill of materials. It's just another report that's going to be built and generated that maps the dependencies that you're using and also the open source risks that you are using. And open source risks might mean that if it's a project that only has a small number of maintainers, or if it's a project that has had CVEs available for a long time and not been fixed, a lot of these kind of sanity checks against these dependencies, that open source risk is part of that software bill of materials, that another report that you're about to do. So, just to summarize, go cloud native, which is not Kubernetes, despite the amazing illustration in there. Think about cloud native in terms of cloud native security that is individual for each of those clouds, but still meets your risk appetites risk appetite, and is able to give you the appropriate controls, native controls for each of those risks. Embrace and maybe fix this cloud security asymmetry in terms of trying to get that crab into a kind of more balanced set of tools, not just focus on the programs, the teams, the technologies that you used before, but build in those new capabilities. And then focus on coverage of all of your inventory, so that when you spill your milk, or when something hits the fan, or when you have those cloud misconfigurations, you know that you're covering everything, all subscriptions, all resource types, and you know what are the appropriate resources to fix them. And then there's a bunch of tools that you can Bing with Google and look out for a little bit more details there as well. That's it. Thank you.